Hello, everyone. Welcome to Mold and Indoor Air Quality, a class from CCHRC. We're just going to give everyone about 2 or 3 more minutes for a few more people to join, and then we will get started. Okay, we will go ahead and get started. Um, Welcome, everyone. Thank you so much for joining us for this class, Introduction to Indoor Air Quality for Homeowners. This class is being generously sponsored by the Golden Valley Electric Association, GVEA, and the Alaska Housing Finance Corporation, AHFC. There will be a section at the end of the presentation for questions and answers. If you have a question presentation, please feel free to put your question in the chat. So before we start, we're just going to ask you guys to take a quick poll and go ahead and answer the questions. And while you're working on that, I will introduce our instructor today. So we are delighted to have Patrick Hartshorn, or Pat. He has 20 years of experience in building science, indoor environmental, moisture management, and energy efficiency training and experience. This combination of knowledge lends a unique insight into the indoor air quality of buildings we occupy every day. Pat has developed a passion for this industry and spends most of his time teaching people how to keep their indoor environments healthy and how to correct problems when they arise. For the past 7 years, Pat has volunteered his time to serve on industry standards consensus boards, developing and rewriting industry standards for professional mold remediation, the assessment of water damage and moldy buildings, and the remediation of illicit drugs, drug residues, and associated chemical waste. Pat would like to believe that he is in the final phase of his indoor environmental career and wants to pass along his knowledge of this industry by educating everyone he can through these incredible resources available from CCHRC and AHFC. So thank you so much, Pat, for being with us today, and we look forward to your presentation.
Thank you. So I've got the class poll screen up there. Is that done?
Should be gone now. Is it gone?
I'll make it gone.
Okay.
All right, thanks everyone for attending here today. We're going to go through this slideshow, which is actually a 2-hour presentation, and we've got about an hour to do this. So we're going to kind of go through them sort of fast. Hopefully the recording that they put up, people can go through it slower and read some of the stuff that we skipped through. Purpose of this course is what is indoor air quality, issues related to poor indoor air quality and the concerns that we have for like occupant health. What do we do to control the indoor air quality? And then basically in the end, we'll just kind of touch on inspections, remediation standards, techniques used by the indoor environmental industry to correct issues when they come up in homes that we inspect. One thing about indoor air quality that I've learned over the years, energy efficiency measures, they need to be thought out, because we have had a lot of homes that have turned into great energy efficient homes, but unfortunately they suffer from air quality issues because they're not, most of the time, not properly ventilated. That's the most common thing that we see. So we'll touch on that as far as ventilation goes. And then what is indoor environmental quality? Indoor environmental quality is the umbrella that indoor air quality falls under. It includes things like lighting, acoustics, thermal, things like that. But primarily today we're talking about indoor air quality. I personally, in my company, I do not deal with the other 3 items. I strictly deal with the indoor air quality, but the IEQ is a very common term that's used throughout this industry. So you'll see that a lot in different things. And there is the IEQ, the 4 different subjects that fall underneath that, but we're focusing on air quality today. Environment, whoops, sorry. So contaminants indoors, there's a list of a whole bunch of contaminants indoors. We do indoor environmental testing for pretty much everything you see on there at the request of clients. The most popular, obviously, is mold, the last one. VOCs and MVOCs. MVOCs are microbial, or mold, if you will, volatile organic compounds. We do a lot of testing for that, but these are the items that fall under the indoor air quality contaminants list for most occupied structures. So, and carbon monoxide, pretty much we've all heard carbon monoxide for that's your combustion, incomplete combustion. We hear stories about that every year where people get sick or sometimes pass from carbon monoxide issues in their homes. And that's something that we really work on hard to try and educate people to how to avoid that. The carbon dioxide, it's the air you exhale. There's levels that are acceptable indoors. To be honest, in homes, I don't typically see the levels too high. The only time I see that 800 is the limit. The only time I see it too high is usually homes that are over occupied and under ventilated. If the combination comes in, we do get that once in a while, but it's more in commercial buildings is where this is a larger concern. Nitrogen oxides, I call them the cousin to carbon monoxide, but automobiles, generators, it's the same thing. It's lack of proper combustion can create your nitrous oxides. And there are lots of known associated health issues that come with every one of these that we're talking about, but I'm not going to go through the whole list here today because we don't have the time, but every one of these, you can go back and look this up during the slideshow thing and see it. VOCs. This is one that is not talked about much. VOCs is a pretty serious concern on indoor environments, and you can see what they're looking at in the picture underneath the kitchen sink there, or bathroom sink. There, you can produce VOCs, but just about everything you do in your house, but it comes from all of the products. So one thing that a lot of people relate to is like new car smell. Everybody loves the new car smell. What they don't understand is new car smell is like 750 VOCs, and it's not necessarily a good thing for you. But fortunately, VOCs tend to off gas and go away. The furniture, things like that have VOCs, they will off gas and go away. But the sources for VOCs in a home is endless. Everything from printers to copiers and printers to pesticides, preservatives, detergents, you name it, they all emit VOCs. The unfortunate thing about VOCs is nationwide, the average, the recommended maximum level is 500. The average level is 1900 nationwide per thousands of samples that have been taken. I think this slide, 45,000 samples plus on this one. I think they're up to around 50 something thousand now. Which shows that most homes have levels that are 3 to 4 times greater than what the maximum recommended amounts is. So VOCs is of a concern, and we do a fair amount of VOC testing nowadays, a lot more than we used to, that's for sure. And there's thing there we go. VOCs in health, the list is long. VOCs can cause an entire list of health concerns for people. That's one of the reasons we like to test it. I get a lot of phone calls where it's just, we would like to test our house for mold because we don't feel good. And then we end up adding in the VOC testing, MVOC and VOC testing, and we find something like benzene. Benzene's a real popular one to find in homes because of garages. Garages attached to houses have lawnmowers or boats and storage, or, you know, just jerry jugs sitting there. And you end up with all of the gasoline exhaust or off-gassing into the home. So VOCs is something to not forget about if you're looking to test a house or trying to figure out why a house might be making somebody sick. And MVOCs are those VOCs that are specific to microbial mold growth, fungi and bacteria. They have studied this pretty extensively, and they have learned what the different, they've been able to categorize the different VOCs coming from different things, and they can tell you if they're coming from a suspect microbial growth somewhere. This is a huge advantage in homes that have water damage that are releasing VOCs because the mold is growing, that's what mold does, but are not releasing spores because the mold is happy, it's got water and food, and therefore spore trap testing, traditional spore trap testing, won't pick it up. But when you smell an odor that you associate with mold growth, that's the VOCs from the mold, that's what you're smelling. It is also a pretty hefty component of sick building syndrome, as you see on there. It's well known in the industry I'm in, but it's not very well known by most people that I come in contact with. MVOC limits, 8 is average, or excuse me, 8 is the recommended max. 10 is what the average home is. So it's not as much as the VOCs, but the MVOCs are still, from all the tests that they've done, are still running high in most homes. So, and then of course, ozone. Where we see the problem with ozone, of course, copy machines and stuff, it is mostly in offices or people who purchase certain types of air scrubbers. So HEPA air machines, things like that. There are a lot of them that produce ozone. Commercially, the use of ozone machines is, there's a misleading thing out there that if you put ozone in a house that has mold, you will kill the mold. That is not true. You can put the mold into a dormancy state while the machines are running, because you're alternating the oxygen for the mold to grow. But when you remove the machines, if the mold is still there and it still has food and water, it's going to start regrowing after a certain amount of time. It'll come out of dormancy and start regrowing. And the commercial ozone industry is heavily regulated by federal law, so it's a very risky thing to do. But for an average household, people who have a lot of electronic equipment, computers, things like that, or those certain types of air purifiers, you can get a lot of ozone in the house. And that is an unhealthy thing to have around. Then of course, bacteria, that's the one where we kind of need that in our house for our children and for immune systems and things like that for growing, but we don't want excessive amounts of it in our house. Commonly, when you find mold growth in a home, you will find bacteria presence also, because water will produce, any water damage starts to produce bacteria as well. And then there's a term right there on the top, residential hygiene. I kind of coined that term years ago. I know a bunch of the guys I work with in the lower 48 are starting to use it a lot more. And that's sort of a how clean is your house kind of a term. If a house is not well kept, the interior hygiene of the home starts to contribute to the air quality by allowing things like bacteria and molds and all of that to grow. So we use that a lot in reports to identify homes that could use to have some tidying up done. And smoke, of course, the picture is of a cigarette, but we don't see that as much anymore. I would have to say that most places I go, the people, if they are smokers, they go outside. That seems to be kind of the thing these days. But there's lots of other things that can produce smoke in a house. Fireplaces and wood stoves is a common one around here. Some outdoor sources where there's forest fires in the summer, there's actually an industry standard just for the cleanup of homes after a forest fire. That is a very specific type of cleaning. Just Sunday cleaning like people do in their home doesn't clean up the residue, soot, char, and ash that's left behind by forest fires or house fires. They can cause things. And if you've seen like the black streaks on walls or long trusses where the studs and stuff are, where nail heads or screw heads are, that's called ghosting. Candles, wood stoves, things like that are heavy contributors to that. And that is a result of having smoke indoors. So, formaldehyde. So formaldehyde used to be classified as a VOC. It was changed to a carcinogen in 2011. And it is in most homes. Unfortunately, formaldehyde's in a whole bunch of stuff we have in our homes. One of the most common products is memory foam. Memory foam is a releaser of formaldehyde or has formaldehyde in it and releases it. So when you purchase things, we teach people that when you purchase like memory foam mattresses or things like that, you really should open them up like maybe in the garage or something, or someplace where you're not going to occupy for a couple of days and let them sit. Formaldehyde is not something you want to breathe a whole bunch of. We do test for it, not as much as we do the VOCs and the molds, but it is known to be in a lot of houses. It is a carcinogen, obviously, but it's also a skin irritant, throat, lungs, eye irritation. So it's something that, again, when people start telling me they don't feel good in their home and they start giving me symptoms, we have to look at the types of testing that could potentially be for products or chemicals or gases that are causing that. And dust mites, that goes back to that residential hygiene sometimes. Every house has dust, some has more than others. And it's, I was like, dust mites don't drink, they absorb. So if you have humidity in your home, high humidity in your home, and you have dust mites, those dust mites are going to be happy. They are very attracted to environments that give them the opportunity to thrive and to reproduce. And dust mites can build fast. They are an asthma allergen. They're a major contributor to asthma allergen conditions for most people. And unfortunately, it's something that can be controlled in a home, but it does take regular hygiene type activities to clean and keep up on a house. And once that gets away from you, you're going to have dust mites. So most people, I just show them a picture of a dust mite, and that pretty much gets them going on the cleaning part. Cat and dog dander. The interesting, it's people think of dander as skin. People get dander like dandruff from hair or something like that. Most animal dander is secreted from saliva, actually. Skin also, but saliva. Dogs that have, that emit a lot of saliva, there's a lot of dander that comes with that. People who live in homes that have dander issues from animals, it can be years before they become allergic to it. They could live, I had a guy who was 70 something years old, I believe, and he had lived with cats his entire life, and at 70 something years old, he became allergic to them. So it can happen anywhere in your life. So it's always something to think, but the statistics are what's interesting on this. 30% of people have allergic reactions to cats or dogs. That's a pretty high number. 60% of households have a dog or have a pet. 90% of all US residents test positive for animal allergens, regardless of pet presence. So you can be allergic to them and not even know it. Just because you're allergic to them doesn't mean they're going to necessarily affect you to a point where you have discomfort or symptoms. But that's a really high number. It's actually more than 90%. So cat and dog dander is something that we do a lot of testing for. It's asthma allergen testing is what they call it. So, and there's the big part of the dust in your home, skin cells. Skin cells can be up to 50% of the dust in home, depending upon occupancy. Humans shed 500 million a day. They are an asthma allergen trigger, and they are respiratory inflammation. When I do traditional mold testing on homes, one thing that is brought back in the report, they look for skin cells because it helps identify sources for food. If you have high skin cell counts and you have moisture present, you're going to grow mold. Mold will use the skin cells as its food source. So it's something that we look for, and it kind of gives us an idea of the overall cleanliness of the home again, based on the amount of the count of skin cells that are present inside of the home. So that's something that we look for a lot. And then amorphous breezes, all of your other things, or all the other stuff. It's mostly synthetic things, like blankets, fibers, carpet fibers. They're almost all asthma allergen triggers. Anything that's an irritant is an asthma allergen trigger. And they can create respiratory distress just based on the fact that they are fibers and particulates that are floating in the air. You can also look at things like asbestos. There's in older homes you can have asbestos present. It's not considered, it's specifically categorized, but it is amorphous debris. It's a non-living organism, so it's fibers floating around in the air. But there's not too terribly much that we do with this. Usually, when a home has an issue, this would not be the main cause. This would not be the main contributor. The molds and the other things are. And we test for those. And if we see high background debris in our sampling or something, then we know that the house has a lot of amorphous type debris present. So, and then here's a subject that isn't talked about enough, and I'd like to touch on this a little bit here. Radon. Recently, there was a study done, and Alaska came in #1 for the highest levels of radon per home on average. The problem with the systems that are out there that tell us about radon levels per state, there's some federal maps and things that are out there. That's all derived from a self-reporting system. So a radon tester would have to get online and do that for every job he ever did to contribute to that list. And that just doesn't happen. People who do this for radon testing for a profession, there's no income to produce or providing information to that list. And it's last time I did it one time, it was 45 minutes it took to fill everything out and do the whole thing per job. That's a lot of time. So somebody did do an independent study and did come up with different numbers. I can tell you, I work with a lot of radon testers. I'm a radon tester myself. We used to have meetings down in Palmer, and we talked about the radon. There's quite a few of us in the room that were doing it, and I would say somewhere in the 50% plus, we get levels of radon that are of concern in homes that we test. So some of the things that come in is some people say, well, I live in such and such an area and we have this type of soil, so we don't have a radon problem. That is not true. Radon, yes, some soils let it through easier, because they're more porous, if you will. But like hard clay still has cracks, just like a concrete foundation has cracks. So it has the potential to find its way into a home. The problem with radon is it's the #2 cause of lung cancer worldwide. And that number is actually increasing. One, because they're doing more studies of people who, there is an actual study out there on secondhand smoke illnesses and or death, where they've been able to go back and test people's homes who were listed as the secondhand smoke. That was kind of a catch-all for people who got lung cancer, but they didn't know why. And they've been able to go back and test a lot of the homes from people and found out that they were high in radon. I think 70-something% of the homes they tested were high in radon. So that brings us back to, it probably wasn't secondhand smoke, it was probably radon. And it's something that can be mitigated. It would be nice. There are a lot of states where it's required now that in new construction that a passive radon system be installed, which is just piping, no fans, no nothing to add to it. And then once the house is done, the owners or occupants have the option to test and see if that system is enough, which I will admit it normally is not. Very seldom does a passive system exhaust enough radon out to get you down to lower limits. But if it is not, at least the piping's all there and it's integral to the home, and you can just add the fan. So I think that's a great building code for those areas. We don't have that here. I don't know if anybody's working on doing that here. It would be nice. But yes, radon can be mitigated. But as you can see on here, it's odorless, tasteless, and has no health effects except for you get lung cancer from it. So it's something I'm trying to put more education out there on, and I'll talk to more people about it and see if we can get more out there. But it's definitely something of concern locally. And as you can see, the pathways for radon are endless. There's just every way possibly get in. See the water well, they show the radon coming out. I do test well water. When I do radon testing on a house, I do collect some of their water, and I have a system here in my office that tests that well water. And I have had 2 residences that unfortunately had already had systems installed to mitigate radon, and they didn't work. Then the testers had actually tested the indoor of the home, found the high levels. They installed systems to one was a sub slab and one was a crawl space to pull the radon out, but the radon wasn't coming from under the house. It was coming from the well. And so they ended up having to put in a burper system for the water after the fact. So we do check that. It is a possibility. It's rare, but it does happen. And now the mold. Obviously part of the fungi family. Not all fungi produce molds. Some are part of our environment naturally. We call those ubiquitous molds. Some are not part of our environment. We call those non-ubiquitous. And when you hear the term black mold, that is a media term developed way back in the Linda Bollard and the Ted Turner cases, that time frame back in the, I believe it was the late 80s. And that refers to the non-ubiquitous molds. Those are molds that grow, predominantly they grow out of man-made materials, cardboards, things with glues and resins in them. They don't typically grow out of like a tree, if you will, or wood. They are molds that are not produced by Mother Nature, and therefore they're not something the human body is used to. So when we start seeing non-ubiquitous molds inside of a home, that raises concern, and we need to address that, or recommend to people that they address that and properly remove those molds. Mildew is actually a plant mold. It's a powdery substance that's on plants. It's commonly used when somebody calls and says, hey, I got mildew all over in my bathroom or something like that. Well, I know what they're talking about. They're talking about mold. In the industry standard for mold remediation, we actually had to define mildew as a word commonly used to refer to mold, because it is that I want to say misused, but it is used in that fashion a lot. So there we go. Sorry, my screen blanked out there for a second. Some spores are already in man-made materials. What that means is when you have products like oriented strand board, press board, stuff like that, spores are trapped in those materials from when they were made. They're in the air. They're around the places where that. And unfortunately, a lot of the wood chips and things that come to the United States to produce a lot of these products, or even products that are produced overseas, a lot of those wood chips are soaking wet when they arrive, because the ships they're brought over in, they actually fill them full of water to keep the wood chips from rubbing on each other and spontaneously combusting. So they're soaking wet when they arrive. They're already moldy, and they build product out of them, which, as long as that product never gets wet, those molds just sit in there and there's no issue. But the day you have water that is introduced to your indoor environment, that mold is already there and it's ready to grow. So that is an issue that we see a lot, and those molds are typically the non-ubiquitous type. They have morphed out of those building materials, and they're not something that's ubiquitous to our environment. So the basics of mold growth. Mature colonies, they produce spores intended for reproduction. They release those spores into the air, and then they're carried to an area where they can land, and they're always looking for appropriate food sources. They're always looking for moisture. And if they find it, they'll germinate more spores. Hyphae emerge from the spore and start to grow. Hyphae is what we refer to as kind of the root structure of the mold, mycelium and hyphae. And then it excretes enzymes. So when you see building materials that have those black stains, that people say, oh, there's mold growth there, or sometimes there was mold growth there and the stains are left behind. That's an enzyme that has been released by the mold that was growing there, or maybe still is, but at least was growing there. And the stain itself is not something that we're concerned about. It's unsightly, but it's not a health concern. And then the stain is not eating the building. The mold is eating the building, but the stain can be left behind. So when we do remediation, a lot of times you'll still see the staining and people think it's mold, but it's not. We do testing to confirm that the mold is gone. If you want the stains removed, that's where a chemical product could be used, which we don't allow in mold remediation, but we do allow it after clearances are done on a mold project. People can come in with a chemical product and, so to speak, I don't like these words, but bleach the wood, if you will, to make it look more presentable. We'll do that in log homes and stuff where they're going to actually see it rather than crawl spaces. And there's the life cycle of mold. So you got your hyphal growth, turns into spores. Spores end up in the air. They find a place to land. They produce more hyphal growth. It's a continuous cycle of life for mold, and it's never ending when you have an indoor environment that is susceptible to growth. So moisture, food, surface to grow on, but moisture, food, and oxygen, that's what mold needs. And then as long as it has any kind of an organic or cellulose-based food source, it's going to produce. And that's really unfortunate that those man-made products provide cellulose, carbohydrates, all of the organics needed for mold growth. The difference being if you get a 2x4 or 2x6 wet, you'll get mold, and you keep it wet and a sufficient amount of moisture, which is not 100%, it's more, say 30-40% moisture content. It'll take 10 days, 12 days, maybe 2 weeks, and you'll start to see mold growth. You get something like oriented strand board wet, it'll start growing mold before morning, and you'll probably see the growth in about 24 hours, maybe a little bit longer, depends upon how much moisture content there is there. So the food source is something that we have in our homes, and so the key is, of course, to try and keep the moisture out so we don't have the growth problem. So mold and health, I'm not a doctor. I don't try to diagnose people with their health concerns, but they call me all the time and tell me they don't feel good. So then we have to listen to what the ill effects are that they're experiencing so that we can orient a sampling plan and we can try to make a decision as to what they might be having issues from. But allergenic, toxigenic, and pathogenic. So that is the issue with mold. There's a lot of science out there on this. Respiratory distress is a big one, asthma allergen triggers. Toxigenic, it produces toxins. So mycotoxins is kind of the big news these days. You can breathe in mycotoxins, and actually they'll start to be stored in your bloodstream, and you'll build up mycotoxins in your bloodstream. And there's a lot of science going both ways, but there's a lot of science out there that says that makes people very ill. I bet I have 30, 40 at least, something in there, of clients that I work with regularly who have high mycotoxin levels in their blood, and therefore they're very ill all the time. And we test their houses and we try to figure out where it's coming from. We can usually do that if it's from an environment that they've been in that we have access to. Some people might get sick from a house they lived in 5-10 years ago, and it just finally comes out today. Well, they don't have access to that house anymore, so that's unfortunate. But and then molds produce the VOCs, the MVOCs, pardon me, like we were speaking of. And then pathogenic, it's infectious. And the big one is it produces aspergillosis. So if you look online, you will find all kinds of information on this. If you wanted to look up pathogenic molds, my advice always has been, make sure what you're looking at is peer-reviewed and credible, because there is a lot of information that is opinionated that doesn't have any backing to it. You want something that has science, and you want something that has been repeated by others to come up with the same conclusion or very, very similar conclusion. So peer-reviewed and credible is something to think about when you're looking up, if you're worried about health effects on the molds. So what do we do about these things? The old saying is dilution is the solution to pollution. So if you provide more ventilation, in theory, you're going to make things better. That's not always true. Diluting the air with fresh air is always a good thing, but you have to control where that air is coming from so you know that you're getting fresh air. If you have a home that is that has a crawl space that has not been kept in good condition, say the home's 30, 40 years old or something, and the crawl space has deteriorated, and in the middle of the winter, all your doors and everything's closed, and you are trying to freshen up your house by running fans, there's a really good chance that there's air coming into that crawl space through, like, say, an old vent or something for a furnace or something like that. And then you're pulling that unhealthy, I'll say, but poor air quality into your house. Our crawl spaces already contribute to our houses through stack effect and other variations just by coming up and through the living environment as they're working their way to the attic. But it's something where when you provide ventilation to dilute the air in your home, you have to know where the air coming in is coming from, and that it is truly actually beneficial to what you're trying to do. So examples of some of the things that are really bad is we've had remediation projects on like duplexes where they use negative air during the process. They negatively pressurize the one unit, and in the end, the sampling is worse than when they started to try and get clearances. Well, we find out after the fact that the house or the place next door is in worse condition than the one we're working on, but it's not our project. So you can do the same thing in your house. If you're living like in an apartment building or duplex or something, you got to be careful where your makeup air is coming from for your ventilation. That's something to always think about. And of course, moisture control. So the side effects of improper ventilation, location is important. The volume of ventilation is important. I think one of the bigger things I see is under-vented bathrooms. No, not blaming builders, but like builders will buy, or whoever installs the fans will buy 4 or 5 fans of the same size and put them in all the bathrooms in a house. Well, the master bathroom might be 12 by 14. The little bathroom might only be 4 by 8. So it's important to size those fans so that they fit properly, where you get the proper ventilation for humidity in those environments that they're being put in based on cubic feet. When we're ventilating, we're trying to reduce humidity levels. We want to decrease the high humidity levels. We want to prevent condensation. We want to prevent microbial growth, and we want to overall increase contaminants. We want to decrease contaminants. I think that's the wrong saying on here. We want to decrease contaminants. That's our focus for ventilation. But poor ventilation or incorrect ventilation, health concerns, deterioration of the building, especially from condensation. We see a lot of homes that have lots of damage on window sills and the lower, if the drywall's wrapped around to the window, that lower section there, from condensation, mostly in the winter times. So lack of ventilation definitely is an issue, or improper ventilation is definitely an issue for that. And the building deteriorates. And then of course the comfort of the occupants. People just typically are not comfortable in a humid environment. And in your house, it changes how you feel the temperature, it changes all kinds of things. And it also increases the amount of particulate stuff that can collect the water molecules in the air, and that's what you're breathing. So there's a lot of concern that comes when you have improper ventilation. And so places to put ventilation in, if you do a whole house ventilation system like an HRV, it's actually designed by the manufacturer to be installed in specific locations for the intake and exhaust. That doesn't always happen in new construction. In fact, it probably happens a lot less than what people would think. There's a multiple different, in a couple slides here, we'll talk about the different methods of installing for HRVs, but HRVs are great, but they have to be located in the right places in the house. Bathrooms, utility rooms, kitchens, attics, crawl spaces, they all require ventilation. Now, attics is typically a passive ventilation system. Crawl spaces, we advocate for the mechanical fan ventilation systems, not the passive venting. Utility rooms would be bathroom style fans, bathroom style fans, and then you have your HRVs. So for whole house ventilation, Heat recovery ventilator is the most popular. They are typically timer controlled, so they run for a certain number of minutes out of every hour, so to speak. And that is something that I kind of have an issue with, because if you have a humid issue going on in your home, something that's producing moisture, it may take a lot more than that to get that moisture out. So that there's other things you can do in your house along with the HRV that are humidistat controlled. So if there is a humidity issue, it'll start to, like, for instance, your bathroom fans, if they're controlled by a humidistat, that will help, because if the HRV doesn't keep up, then the bathroom fans will kick on and get the humidity out. They do have booster options, which are great. So if you're doing something where you're producing humidity, you can crank them up to a higher rate. I'm not sure if the booster options run them for a longer amount of time, but I think they do. Here's the installation thing. There are 3 different primary types of installation for HRVs. This is a manufacturer's recommendations: new construction, then there's a retrofit design 1 and a retrofit design 2. In a new construction, HRVs are considered to be about 75% efficient. That number may vary depending upon the brand. In the retrofit 1, which is where they still pull air from the bathrooms and laundry rooms and the moist and the kitchens, but they supply air back to the furnace returns. So every room in the whole house gets supply air coming back, but only the moist rooms get air pulled out. According to the manufacturer I spoke with, that's about 55% efficient as far as heat recovery goes. And then retrofit 2 is just plumbing it right into a furnace, supplying return on either end of the furnace, and they just let the furnace ducting do the job, and that's not very efficient. So I will admit, in new construction, unfortunately, the most of what I see is retrofit 1. Very seldom do I see the HRVs supplying returns in every room in the house. It's usually just the bathrooms, laundry rooms, and kitchens, and then they plumb them back into the furnace system. That's the next statement. The other thing about HRVs, are misunderstood by a lot of people. They don't understand why that thing's in their house and what it's running for. People who purchase a home normally are not educated on what the HRV is supposed to do, so therefore they're under maintained regularly. We see a lot more of them that you open up the box and they're just plugged with everything from the exterior, so there's no air coming in. The filters are plugged, they just do not get maintained. And one of the problems, I think, is because the location of them is typically either in a crawl space where most people don't go, or if it's in a garage or a closet, it's all the way up there by the ceiling. And so location is probably a part of that. And I try to work with builders and educate them on bringing those things more into because they are a maintenance device, and has to be maintained every 3 months. So some people say every month, but it depends upon the area you're in. You need to check them a lot and get a schedule going. And there's a lot of construction where they use the HRV as a bathroom fan, and they do not install bathroom fans. The manufacturers that I've spoke with, the HRVs, said that is not their intent, and they should not be used for that in a cold climate environment. Maybe they could be used for that in other areas, but they should not be in our environment. They're not designed to be a single source use item. They're a whole house ventilator. And then there's energy recovery ventilators. I am not up on these. I know of them. I know there's some around. They've been being put in. CCHRC may have information online on those, because I was told they did do a study and that there was positive results on that. So that's something that I'm going to study, and I'll add into my courses later on. But and for installers, so I asked builders and I asked people about these things when I talk with them, and the jury's out on them. The guys are saying they work great in Florida, so to speak, but they don't work up here. Well, I don't know. I would like to see what CCHRC comes out on that, and that's who I'll trust for the information on that one. Point of use ventilation. So exhaust fans only. This is honestly what I did in my house. I put in all bathroom fans in every bathroom, in my main living spaces, and then of course I had to put in air makeup as well they call them fresh 100s in my walls, but they all run on motion and humidistat. So if there's moisture in my house, these fans that sense the moisture, they kick on and run. Then they will run until that moisture is gone, and then they'll shut off. If you go into a bathroom, the humidistat automatically, excuse me, not humidistat, the motion sensor automatically turns fan on. And that fan runs while you're in there moving around. And when you leave, 30 seconds later, shuts it off. But if you took a shower or something, you produced humidity, and that humidity will cause the humidistat to kick in as well in the background, and that fan will run until that humidity is gone. That's the drawback I see to the using HRVs as bathroom fans, is because they're timered. And so if a person took one of those really hot teenager shower kind of things and then filled that bathroom full of humidity, there's a really good chance that timer is going to shut off long before that humidity is gone. And so that's why I am a fan of the exhaust fan only type of system, but I'm not against HRVs by any means. Don't think I said that, but I think in combination, if the two are installed, you've got the ultimate. They're great for humidity control, but the nice thing about HRVs is they are refreshing the air all day, every day, even when you're not around. So there is a big advantage there. So exterior makeup air systems, yeah. So that's what I put on mine. And in bathrooms, when you do a bathroom fan to ventilate a house, again, the ventilation is designed to keep the moisture out so we don't get mold growth and other contaminants come along with that. Those bathroom fans have to be sized appropriately. That is the big one I think that we see the most, is they're just generic purchase of certain CFM and they put them everywhere, and whether they're the right size or not. They are required to be a low zone constant duty design fan, because they are just, if you put them in there, they have to run be able to run 24/7. You can be humidity, timer, motion, or manually controlled. I don't have switches on the ones in my house because I don't need them because of the motion sensors. So that's something to consider. If you go with fans that have motion sensors, you don't need switches to run them, because if you're there, they're going to run. So I have one unit. As for humidity control, there is makeup air requirements. Don't forget that when you do the bathroom fans, it doesn't have its own source of return air. So you do have to put in some sort of makeup air in your house. And the cons to them, of course, they're not filtered. So the air that comes in is not filtered. So you don't have an advantage there. They're like HRVs do have some filters in their air. The covers require cleaning regularly. I should have put most overlooked after that also. Bathroom fan grates and the fans need to be cleaned regularly. The air guy here locally that does the duct cleaning guy, he has some NATCA certifications, and one of the training things he gave me was that if 1/2 of the openings on the grates has dust on it, you're down to about 30% efficiency of that fan. We see these fans regularly that are way more than half of the openings are gone. And I have a routine in our home where every April we pull our fan covers down, and it's 2 screws and the whole fan center comes out, and we spend a half a day and we clean every fan in this house, and then we put them all back in. And it's amazing, with as clean of a house as we keep and with air scrubbers and everything going in my house, I still have fans full of dust. So it's very important to keep those things cleaned. Interior cleaning. Duct requires cleaning as needed. Duct cleaning is another subject that people don't typically talk about. We recommended it like a time of home sales, but I think if I remember right, NATCA is every 5 to 7 years, you should have all the ducts in your house cleaned. Some of those ducts would be your fan ducts, your dryer ducts, and any forced air heating. So that's something that is overlooked regularly. I've got lots and lots of pictures of return vents for furnaces that 1/2 to 3/4 of the entire vent is completely plugged and there's no opening left for air to get through. Utility rooms are another great place to exhaust your home for moisture. Dryer exhaust, remember, it's to the exterior only. We do not exhaust dryers into our buildings. People think that's a saving heat. Well, if you have a gas dryer, that's extremely dangerous, but you're producing so much moisture. The average load of clothes reduces about 8 pounds when it's dry from the washer to the dryer, coming out of the dryer. Well, that's a gallon of water. So it is very important that dryers be exhausted to the exterior. It is recommended that ventilation fans, but it's not common to see them. It's recommended that they be in the laundry rooms, but it is definitely not common. And that fan can just be on humidity. It doesn't need to be necessarily a switch fan or have motion control, but it could be on humidity if a person wanted to. The motion would also be something that would be good in it, but it doesn't have to be on motion in that location. And then makeup area considerations. My laundry room in my residence is in the back of the garage, so it has a fire door, and I forgot to put in a makeup air for that. And my dryer, when you tried to open the door when the dryer was running the first couple times we ran it, it about yanked the door out of your hand because the room going to negative pressure. So you definitely have to consider makeup air for a laundry room, and that does get overlooked quite often. And then boiler furnace, water heater rooms. And again, they're places that have moisture. So there's nothing wrong with putting exhaust fans in those locations, just as long as you have the proper controls again, so that you're not just putting a fan there, it's never going to get used. Heating appliances also exhaust to the exterior only. That's definitely something that I think is most people understand that. The ventilation fans are getting recommended, but they're not common. Excellent location for humidity control, as with all the other places that produce moisture. And then don't forget your makeup air in there as well. Kitchens, we have the range hoods. One of the problems with range hoods is they're noisy, so nobody likes to use them because they always want to have conversation while they're cooking dinner. So, and the grease screens require cleaning. We see that does not happen quite regularly. It's not uncommon to see those completely plugged up, so they're not doing anything. And the microwave designs over the stove, I'm not sure what's going to happen there with over time, but there is talk of they're trying to get building codes to prevent microwaves from being over stoves. I know it's hard to keep your distances for building code, but also the rate of injury from microwave, putting stuff in and out of microwaves. I don't remember the exact number. I want to say it went up like 500 or 1500 or something % when they started putting them over stoves. And I can see that because kids and just people in general that have to get up and put stuff in and out of a microwave over a stove, if that stove's also being used, there goes your injury rate right through the roof. Kids probably put their hands on the burners or pulling stuff out of a microwave that's up that high. So we advocate for those things to put microwaves in the cabinets and go back to a standard range hood above the stoves. And then attics. Older homes did soffit and gable end ventilation. It's not as effective as a ridge vent. So when modern construction, ridge vents are pretty much what they put on. And when roofers go in and put new roofs on older homes, they tend to add the ridge vent. That's sort of an upgrade. One of the problems we see is they don't block off those gable vents on the inside when they put the ridge vent in. And the instruction courses that we have from a guy down in Florida has shown that, you have to have that soffit lower intake air to capture all of the moisture that's in the attic to draw it up and out that new ridge vent. And if you leave the gable vents, they start to become the intake. And then all of a sudden the soffit vents stop working. And we have been in many houses where that has been 8, 10, 12 years after a ridge vent's been added. And the lower portions of the attic sheathing are moldy and sometimes completely rotten because there's no ventilation going on down there. The air becomes stagnant down in the low section, and the only ventilation is right at the peak. It's coming in the gables and out the ridge. And so we try to educate, especially roofers, on that, but anybody who's dealing with that, addition of ridge vents and stuff to get rid of those gable vents. So there it is. The new homes use the ridge vent and the soffit. So there is a recommendation that we've been using until somebody tells me different. We've been saying 1 square foot for 150 square foot. There's a lot of controversy in the industry as where that's supposed to be. That's the number we've been using. It seems to work well. We do not recommend power venting here in Alaska with the cold climate situations. That creates pressure differentials that we can't control. I don't recommend those turbo vents be added to a house that already has venting. If you have an issue in your attic with moisture and mold growth and things like that, figure out the proper venting per the ridge vent and or gables and soffit venting. Correct the problem for venting. Don't add more vents, if you will, because it's probably not going to work. Then there's that last one, ridge without vents. Crawl spaces, that is a huge subject that I do. About 75% of my work is crawl spaces. And unfortunately, most of that is new construction from water damage, but ventilation system crawl spaces, there is 100 different ideas out there. There's different people teaching different things. What I have found works the best for what we do, which is water moisture control and mold, trying to keep mold out of crawl spaces, is a humidistat controlled bathroom fan in a corner with the humidity switch at the fan. You can't put the humidistat switch out in the middle because you're trying to exhaust humidity from a source, which is the fan. You need the switch to be at the fan, so when the last of the humidity arrives and leaves, it will actually shut the fan off at that point in time. If you put the fan out in the middle of the crawl space, you don't get drafting, so you don't get as good of ventilation. And if you don't put the switch at the fan, you don't get as good of exhaust. There's a lot of information on here about that, but I gotta keep it going. And same information, we set those fans 40 to 45, somewhere in there. They don't need to be high CFM fans. We're not trying to, completely negative pressure the crawl space. We're trying to provide just air movement enough for moisture to follow that movement, which is not take much. Pressure differentials don't need to be that very high for air or for moisture to follow that. Vapor barriers, very important. Vapor barriers be continuously sealed and 100% sealed as possible. Just one of the things I dealt with today is sump pump in a crawl space where they just cut a big hole in a vapor barrier and put a sump pump in. Well, you just eliminated the entire reason behind the vapor barrier in the first place. And now you have a sump pump that's collecting moisture, has an open top, and it's just providing moisture to the crawl space. There is actually a lid system designed for vapor barriers that seals the sump pump. So it seals the top of the sump pump and the vapor barrier together. And it's an inspection lid that you can actually pop off and work on the sump pump. So there's things for that. And then heating HRV supplies. There's an argument in the industry that if they are tied to your crawl space, so if you have an HRV pulling air from your crawl space, or your forced air furnace is supplying air to your crawl space, some of the duct guys will say that's duct leakage because it's uncontrolled. It's not something we recommend. And I will say that on homes where we have crawl space issues, that we do air testing prior to our remediation, we have mold issues in a crawl space. Most of the ones who have openings in either the duct system or the HRV end up with spore related concerns in the living space as well. The ones who don't have those openings, we don't typically get those results. So I believe that openings in the crawl space, you don't need to supply heat to a crawl space that has furnace ducting and or a furnace down there. They stay plenty warm at the coldest of days just by the presence of those hot metal items. So you don't need to supply that extra heat. And then that residential hygiene term. It's the overall cleanliness of an indoor environment. So air quality is affected by everything that can produce particulate, that increases the humidity levels, the things that, the dust mites, the bacteria like to grow on, the dust mites like to eat, the mold likes to grow on. Radon can connect or can basically become part of and connect to airborne particulates, so it can be held in the home longer where it doesn't get out as fast. There's all kinds of problems that come with keeping a home less tidy, if you will. And so we're advocates of people, and sometimes I go into homes and I tell people I can't even air sample your house because it's with the amount of stuff you have or the way the house is kept or something. And I don't like these conversations, but we have to have them. We can't air sample this house until these conditions are corrected, because the air samples aren't going to look good just based on the environment that we see. So it's something that we work on a lot, is trying to help people understand what residential hygiene is and how to keep it from becoming a problem. In the industry standards, there's conditions 1, 2, and 3. Condition 1 is basically an average clean home that doesn't have a history of water damage. Condition 2 is where a home has a history or has a present water damage issue, and now it's got spores and all these other things settling on all the surfaces, and people are breathing those things in the air. And then condition 3 is physical visible growth on a surface, mold growth on a surface. Remediators use negative air practices to protect environments and to start, if you've got a room in a house that's moldy and you want to keep it from getting out into the other rooms before, if you catch it before it's too late, you can put that room under negative air, and that's going to protect all the rooms around it. Damp wiping, HEPA vacuuming, there's all kinds of things that come with remediation practices that are not common to household cleaning, and it takes classes to learn how to do those. Building materials then and now. So basically what this slide talks about is the building materials that we built houses out of pre-1990-ish were mostly non-man-made materials. There's a lot of man-made materials out there, so don't get me wrong, they've always been around. But they were, even if they were man-made materials, they were made out of things like real tree wood, that, forest trees, if you will, things that didn't support mold growth as well. After about 1990, when a lot of the oriented strand board type products and everything came onto the market, MDF came in somewhere, I'm not sure what years it came in, we started to have more and more mold problems. So in all honesty, a newer home is more likely to grow mold than an older home. In an old home, you pretty much have to put water to it, and you got to sustain that water long enough for mold to get rooted and start to grow. And it's probably going to be ubiquitous molds, not these non-ubiquitous molds. Newer homes, if you get a little bit of water now, the molds will get rooted. And if you just sustain a humidity level, they will continue to grow. So that's one of our concerns with modern homes, is it's more important to keep them properly ventilated and dry. And this talks about oriented strand boards, the oriented strand board products. There is an association. I've been working with them for a while, but they're, I'll be honest, they're not very responsive on stuff. But the Engineered Wood Association, they kind of control this industry, the engineered materials industry or man-made materials industry. There is a lot of stuff that we put in houses that is under their guidance, if you will. And you can see some of the lists down there. And so then plywood, there are some things that are advantages with plywood. It doesn't swell up like oriented strand boards do. It typically doesn't discolor. It doesn't absorb moisture like a sponge, where the other ones kind of do. We've kind of talked about these things, but it's a better product. It's also sometimes plywood isn't as feasible either, so that's kind of why it doesn't get used. And then this is about OSB. We already spoke about that. And again, I apologize for going through these so fast, but we only have a certain amount of time, and we're kind of almost at the end here already. So, and then remediation. This is the big problem with, there's industry standards, best practices, if you will, for how to remediate water damage in your house, mold in your home. And there's even industry standards about how to evaluate the water damage and mold. So there's S500, S520, and S530. The S520 is the most important one, because that's the mold, the actual mold remediation. That standard, it says here, new release 3 of 24. Well, I got news for you. It just came out last Wednesday. So I need to update that to 5 of 24. It's a brand new standard on the market today, most recent science. And mold remediation is a removal process. It is not a chemical process. There are no chemicals allowed on mold remediation because they don't do anything beneficial. So these are things just to keep in mind, and that remediation is done very specifically, remove the mold. Then it is the standard of care, the prudent practitioner. That's a term used to say that what would a person that's remediating something or cleaning up water damage or something like that, what would they do under normal circumstances following industry standards? That's a prudent practitioner. Chemicals are not something that we use. They in a lot of cases produce more problems than the mold itself. And one last thing here, did you know anything that claims to kill, destroy, repel, or mitigate a pest is in fact a pesticide? So when you talk about people want to bring chemicals into your house to try and attack a mold, they're bringing a pesticide in your house. And that's where we say a lot of times what you bring into the home can do more damage than the mold itself. So pesticides are not something you want in your indoor environment if you can help it. Also, it's not on here. There are federal laws that control pesticides. Alaska also has a very specific law. It's Alaska Administrative Code 18.90, and then in there, you can't apply pesticides unless you have a pesticide applicator's license under most circumstances. So that's something to consider too. So anyhow, I've gone through these. Does anybody have any questions in relationship to what we just talked about? Oh, Sophie put a thing in the chat that they do. So there is is there a study that you guys completed? Is that what this is on the ERVs? Oh, Sophie's muted. Rose is muted.
Sorry. That is just some of our research. There was a research done a few years ago on, yeah, some of the uses of air exchangers. You can read that in more depth. I personally have not read up on that, but something for sure to look into. You have a question from someone in the chat. If you know you have black mold in your house, it's visible, what would the first steps be to remediate it?
So we tell people when you see mold, don't touch it, because the most common way to get mold airborne is human activity, human intervention. You have to decide where's the mold, what's it on, and what is the best way to collect it. So I don't know where you would be talking about in the house, but one of the common ones, so bathrooms get moldy a lot because of lack of ventilation or lack of use of the fan or all those kind of things. Well, that's drywall. And if you can catch it right off the bat, that mold is probably eating extracellular material on the surfaces. So just gunk on the surfaces. And if you can get that cleaned off with soap and water right off the bat, a lot of times you can prevent that. Of course, you want to fix the ventilation. The mold's not there because the mold itself, there's a problem. Then you got to fix that problem. So that's the focus. But if you can get that wiped up with soap and water right off the bat when it's a very, very small issue, that's fine. But if it gets rooted in and you go there and try to wipe that off, you're going to put the spores in the air. And that's just going to create more mold growth somewhere else. Houses get bad enough when I've had house people try to keep cleaning up the mold and let it go and let it go. And like every morning they'll get up and they look in their toilet bowl of all the things, and there's a ring of mold around where the water line is. That's mold in the air landing there. And of course, there's some food source there, and all toilets have food source. And so every morning they have mold. Well, that's because they have so much mold in their air, it's just landing everywhere and finding food sources all over the house. So don't put the mold in the air. That's the primary thing. It's on drywall, but inaccessible. It's behind a set of corner kitchen cabinets. You got to get to it. Here's the other thing about your first question was, what would the first steps be to remediate? Air control. Don't mess with the mold. Set up air control. So when you do go to address the mold itself, the spores you're going to put in the air, they're going to go to where you tell them to go. You're not just going to let them fly through the air and become a part of your house. You're going to either collect them in a true HEPA vacuum and then remediate, or you're going to pull the moldy materials and stuff off the wall with air control in place, which can be a HEPA air scrubber sitting right there. It could be negative air and that's pumped out a window so that it grabs that mold and pumps it outdoors. There's so many different factors. Each and every job is kind of unique in of itself. But for homeowners, I always tell them, call me. I talk on the phone all day long, giving people advice on how to deal with mold stuff. We don't charge for that kind of stuff. So it's education. And that's my goal, is to educate. So if you have it in a location on drywall in your house, drywall pretty much, it's a throwaway only. You can't get mold off of drywall. Like I said, in that bathroom, you might be able to. That's the only place in the house I can think of it. You might be able to catch it right off the bat and wipe it away. And if it don't come back, you won the game. But if it comes back, it's in the paper. And then you have to cut the drywall out and throw it away. That's the unfortunate thing about drywall, is there's no way to get the mold out of it. I don't know of anybody outside of Fairbanks or in Fairbanks that is I don't know of any certified remediation firms in Fairbanks. Um, uh, Sophie or Rosa, do you guys give out my email and stuff with this?
We're more than happy to share your email if you'd like us to.
Yeah, the info one. Because that's a good way to communicate with me. And like I said, I'm always happy to answer these questions, but I will look online first thing in the morning and see if anybody has become a certified firm out of Fairbanks. I don't know of any, but as far as I know, there's only 4 in the whole state. 3 are right here in Wasilla, and 1 is on the Kenai. But there are people that are perfectly capable of going out and doing mold remediation. It only takes a phone call to educate somebody on each, for each job, to educate somebody on the methods that need to be applied to the remediation process, and they can go out and do it. Not a big deal. So, and homeowners can do it themselves too. I can talk to homeowners and tell them what they need to rent, and they can go out and rent the tools. There's places that rent out HEPA air scrubbers and HEPA vacuum cleaners, and it's definitely something a homeowner can do on their own. Oh yeah, that's my correspondence email with clients and stuff. So for questions and stuff. But
I had a question. So, when you were talking at the beginning of the presentation about like typical household cleaning things you can do, are you really just talking about like vacuuming, and is that a good way to prevent pet dander, or are there other, everyday steps that you would recommend for typical homeowners?
are you speaking to pet dander alone or to all kinds of things?
Pet dander, dust mites, whatever those classic things are.
So a lot of people nowadays, the big kick is the HEPA air scrubbers. You can buy HEPA air scrubbers at your local hardware store, the Walmarts and everything else. You can buy those air scrubbers. They work good, but the misunderstanding is they work good at keeping a properly maintained environment clean. They do not fix problems. So remediators use HEPA air scrubbers on jobs, but those are huge 500, 600, 700, maybe even 1200 CFM machines. The ones you buy to put in your house are much smaller. So HEPA air scrubbers running 24/7 on low speed or whatever are constantly cleaning the air. So that's a good thing to have in your house. The problem with vacuum cleaners is you see, HEPA vacuum cleaner. You go to the local store and you'll see HEPA on all these vacuum cleaners. Yet, look at the vacuum cleaner. The dust collection tray is plastic, stuck into a plastic chamber. There's no gaskets, there's no seals. It's all gaps and openings. And so when you're using that vacuum cleaner, you're re-emitting all of the fine particulate back to the air. And there's massive studies on this out there, a whole bunch of studies on how the air quality decreases during the vacuuming process. We're not allowed to sample a house until a minimum of 2 hours after a vacuum cleaner's been run, because the air quality is horrible right after a vacuum cleaner's been run. And the proper thing to me, and this is what we own here, is a certified HEPA vacuum cleaner. You want to really keep your house clean and collect dust mites and danders and all that kind of stuff, vacuum with it. Buy yourself a certified vacuum cleaner. Sure, they're a couple $100 more than the $200 Walmart one, but they're sealed. The units have rubber gaskets on everything, and they're sealed. That's the key. So there's keeping up on that. And then as far as your physical cleaning goes, soap and water. The big, and I'm not one of these guys who pushes, you got to have all green products in your home. If you want that, awesome. But a lot of the products that are out there on the market that people use on a regular basis, let's just say the advertising that they sell those things with isn't necessarily 100% accurate, and they're not, a lot of those are not very good for you. And there's a famous person in this industry, I won't mention her name on here, but there's a famous person in this industry who taught us a class years ago. And when people started talking about some of the cleaning products that are for supposedly kill mold, and how, just use bleach and all these things, she says, you know what, if you want to use bleach, just go lick the mold up. It's healthier for you. So those are things to think about. It's Why would you bring something into your home to try to clean up a problem when the product you're bringing into your house is worse for you than the problem is? So that's always keep that in mind. We're advocates for soap and water. Remediators use laundry soap and water to wipe down surfaces in a house. Every soap has a different focus on what it's for. Soaps are surfactants, they have surfactants in them. And laundry detergent is designed for particulate. Joy soap is designed for grease, grease and oils. You know, dishwasher soap or dish soaps are designed for greases and oils. So most people use laundry soaps actually, and that's what they clean their house with. Most people that we've done jobs with or had education with, they use laundry soap and water and they clean their house with them. But we live in a different world than we used to. We don't seem to have time to. My mom cleaned the house every Sunday religiously my entire growing up life. We don't do that. I don't have time for that. So it's hard. And when you're dealing with pet dander, unfortunately, some people really, really, really love their pets and they kind of run their household. And that's very hard to keep up on. But that is discussing it is the saliva that the dog is flinging all over your house. Well, that saliva is going to dry and then it's going to become particulate and it's going to aerosolize. HEPA air scrubbers are a great way to keep that cleaned up. That, you know, because they're always working for you. They're always going. So, but you have to clean those filters. You have to take those things. And that's an area. If you ever put HEPA filters in your house, take the things outside to pull the filters out to clean them. Don't pull them out in your house because you're just giving a great big bloom. That's just like the vacuum cleaner. You're just blooming stuff all over the place. Yeah, take them outside and clean them out there and reverse vacuum those filters out or replace them if you want to. Either works, and then put them back in there and you're good to go. Well,
Thank you. As a dog owner, I'm totally guilty of that, and I think I'm happy to learn more in this class. Are there any final questions?
that sounds like it.
All right. Well, in that case, I want to thank you, Pat, for a wonderful and really, really fascinating presentation. We also want to thank our sponsors, GVEA and AHFC, for generously sponsoring tonight's presentation. Please answer the poll questions. They help us make the classes better for the future. And this was the third class in our 3-class series, but we typically run class series twice a year. So keep your eyes open for our fall class series. And if you want to join our newsletter to keep up to date with all of our news, you can visit our website, cchrc.org. Thank you so much for joining us tonight. Thank you again, Pat, for a great presentation.